Welcome to the physics class, BSc Physics, third semester, paper name Geometrical and Physical Optics, Electricity 1 and Basic Electronics. In this paper, unit 3rd, Theory of Dielectrics and Moving Coil Galvanometer, session 4, we studied about the electrical polarization and atomic polarizability alpha. So, dielectric polarization or electrical polarization. So here we considering in two parallel plates of the capacitor. They are separated by a certain distance. In this gap we have to apply into a dielectric material. After the application of the external electric field E naught in the forward direction, due to the application of the electric field, the displacement of the charge of the molecules of a dielectrics under the action of applied electric field is obtained. This leading the development of dipole moment is called the dielectric polarization. This means after the application of the electric field in case of the dielectric material, the positive charges of the atoms, they are aligned in the direction of the applied electric field, and the negative charges are pulled in the direction of the opposite to the electric field. Due to this, negative and the positive charges will form a dipole moment, that is distance d or x. These dipole moments, they are aligned in the direction of the electric field. All the atoms in the dielectrics, it will be obtained as a dipole moment. The resultant dipole moment, it will be forms as a dielectric polarization. The process of producing electric dipoles by applying of an electric field is known as an electric polarization in dielectrics. When an electric field is applied to a crystal or the glass containing positive and negative charges, see this side, two parallel plates having a positive and negative charges. The positive charges moving in the direction of the applied field. The positive charges, they are moving in the direction of the applied electric field, and negative charges, they are moving into the opposite to the electric field. This displacement of the positive and the negative charges, it will be forms as in this displacement of the positive and the negative charges will forms as in dipoles or dipole moment. This displacement will produce as the local dipoles throughout the solids. So this creates the internal electric field, which reduces the overall field within a dielectric itself. Total dielectric will be this in case of in the absence of electric field. After the application of the electric field, the dipole moment, it will be dielectric will be reduces to the electric field. From the macroscopic point of view, the sum of the dipole moments of the given volume is given by total volume will be dipole moment will be obtained, that is equals to the solids having a large number of atoms, means n number of atoms. The dipole moments, it will be given by summation of the I is equals to 1 to n delta V into mu I, which is equals to n into mu bar, which is also equals to P into delta V. Here n is the total number of molecules per unit volume, total number of molecules in presence of dielectric material per unit volume, and mu bar is the average dipole moment of all the atoms. Now P is the dipole moment per unit volume. P is the dipole moment per unit volume is called the electric polarization. Now we see the electric dipole. So electric dipole means It is a system consisting of two equal and opposite charges, that is plus q and the minus q are the charges. They are separated by a small distance. Here we seen one charge plus q and the minus charge. They are separating by a certain distance small d. It is called as an electric dipole. Next, electric dipole moment. Electric dipole moment. The product of magnitude of the charge and the distance between the two charges is called dipole moment P. So vector P, which is equals to the product of Q into D. Here Q is the charge of the particle, D is the distance between these two particles. The unit of dipole moment is Q is the charge. Charge it can be measured in terms of coulombs and distance it will be measured in terms of meter or centimeter. That is dipole moment of the having an SI unit coulomb meter. It is a vector quantity. It is a vector quantity pointing from the negative to the positive charge. So it is a vector quantity negative from the polarization vector. It will be acts in the opposite to the direction of the electric field. Electric field will be applied into the positive to the negative side, and polarizability will be obtained in the direction of negative to positive side. So that is the definite arrow mark will be represented into the opposite direction of the electric field. Next we seen about polarizability. Alpha, it is represented by alpha. That is the strength of the induced dipole moment P in a dielectrics is proportional to the applied electric field. That is P is the polarization is proportional to the applied electric field E. So when we proportionality constant will remove, we will getting the one constant term will be added. Therefore P is equals to alpha into E. Here alpha is the constant or proportionality is called polarizability. That is represented. We will get the alpha is equal to P dividing by E. So this is alpha is called as an polarizability of the dielectric material. So next we seen about atomic polarizability and molecular polarizability. So atomic polarizability is defined as the electric dipole moment induced in an atom by an electric field of unit strength. Next, molecular polarizability is also defined as the electric dipole moment induced by the molecule in an electric field of unit strength. So today's class we learnt about what is meant by dielectric polarization or electrical polarization in dielectrics and what is the direction of that dielectrical polarizability and electrical dipole and electric dipole moment and polarizability, what is meant by atomic polarizability and also molecular polarizability. Thanks for watching.